here to talk about Micrometer or Micrometer. Doesn't matter. My name is Clint Checketts. My claim to fame is I'm the person that opened the issue that eventually turned into Micrometer. And so I've been working with the project from the very beginning. And yeah, Micrometer, Micrometer, doesn't matter. But so I work at the Church of Jesus Christ of Latter-day Saints. And I've been contributing to Micrometer from its inception, from when it was initially called Spring Metrics. Okay, so the goal of this presentation is actually become a very quick introduction, and then a deep dive into a number of features of Micrometer that make it very easy to adopt and use in your projects. So we're going to talk about how can you use Micrometer, so very initial things. How can you control the number of metrics? Because what happens is, once you have one metric, you want 2 metrics, and then you want 20 metrics, and then frequently it turns into 10,000 metrics, which that's not a bad thing, but at the same time you want to be able to control that. If you're currently using X for your metrics, say some old system, and you want to use Micrometer to help you transition to a new system, we're going to cover that as well. And then there's a case where you might have some common data that you want to include with all your metrics, maybe the region or the cluster where you're running your stuff. And we're going to cover even more stuff than that, so we've got a lot of things. And what better way to start off a presentation than with a demo? So this is what the demo is going to be. We've got an app that's instrumented with Micrometer, and then we're using Docker to go and start up a monitoring system so you can see it locally. And the monitoring system we're going to be using here is Prometheus, and I'll explain why in a bit. But you can use, as you probably know coming into this, Micrometer supports many backend systems. We'll also be spinning up Alert Manager, though we won't be looking at that, and we'll be looking at Grafana just to give you an overview. There have been other presentations that have dug more in depth with those parts, but I'll give you a quick overview of how those work. Okay, so all the code and the examples that I'm using here are available on GitHub under my username Checketts at Micrometer Spring 1 2019. I'll put the URL up on the last slide of the presentation anyways. There's this very nice feature with Docker called Docker Compose. And this is where you can have a file and just point to this file and it'll go and start up all the containers you need with the right parameters, right environment variables, things like that. So the main thing I wanted to point this out for you is after the presentation, if you say, how could I spin up a Prometheus and Grafana very easily, then you could just run this command. So in here you'll see we've got a Prometheus that's going to be running on port 9090 and our Grafana on port 3000. So let's go to the command line. I'll kill the one that we had running right now, just so you can see how to run it. Postgres wants to hang on. And while that's doing its thing, I'm actually going to go and kick off a bunch of curl commands in the background so that can create some traffic for us. Oh, I guess they're still running. All right, so let me make that a bit larger because the resolution on this isn't as great as I'd like. So to use Docker Compose, you just go to the directory where that Docker Compose file is, and you'll do Docker Compose up, and that will pull down all of your images, start them up, and get them running very quickly. So there it is up and running. So let me give you an overview of just a very high-level overview. So here we have Prometheus, and it's monitoring several targets. It's got our demo app that we'll be looking at. It's monitoring itself, and then a user app where I wanted to give you kind of a microservice kind of way to compare how those are looking. It's scraping that every 30 seconds, and so if I go and stop my app, let's see, where are you at? We go and stop it. Then Prometheus will, when it goes to scrape it, it'll see, oh, it's not there anymore, and not be able to get those metrics anymore. So let's go start it back up again. And one other thing that Prometheus is doing is as it's scraping those metrics, it's recording them, and so we can kind of look to see how they're going. So here, our demo app was showing as a 0, meaning it was down. It wasn't recording data. Don't worry, we'll tile this in. So, and here you can see the graph. We're going to be fighting this size for a bit. Let's go and query that. So here you can see that our user service is up. Our demo service was recorded as down, and now it's back up again, now that we restarted it. So that's just a quick overview of seeing that Prometheus is there and how it's talking to stuff. The part that's going to be most interesting is Grafana, which let's load this up real quick. So this is a quick dashboard so I can kind of demonstrate how these metrics work. So Here we have the HTTP request that I'm collecting on the back end. And you'll notice something very interesting about this chart. Businesses love counters because they always go up and to the right. So here you can see that it's always just going up. This is showing a metric of how many requests it served, right? And so in this case of the API hello is serve 4, 13, and so on. It's going up all the time. So this is what's called a monotonic function. So counters in Micrometer, and we'll dig into these some more, don't worry, always go up. And if they ever go down, then that implies something important. For example, if the system knows that this number will always be going up, if it ever goes down, that implies a restart has happened. And so then it can take that into account and make sure that the charts make sense. Does that make sense? Let me show you what that means. So here we've got the same metric over on the right side. And instead of just showing the raw count, it's going to show how much has that count increased over time. So the query here is it's saying over the last minute, how much has that gone up? And so that lets us see how many requests a second you're serving, right? So in the case of these other endpoints, you can see the 8, maybe you can't see it. There you go. So we'll in fact filter that. So we can see that it was serving about 16 to 20 requests a minute before, had the restart, and it picked up where it left off. So I realize that's a very brief overview of what Grafana is, but I wanted to let you see kind of what the end goal is. And there was a good presentation yesterday by the guys from Charles Schwab where they got more in depth in looking into those bits. But that was mainly I wanted to show you what the end goal was. So now taking a step back, I want to talk about what Micrometer is and what its purpose was. With Spring Boot 1, there was a nice Actuator metrics endpoint, and you could look at it and you could go and see various metrics. But the problem was there was this next generation of monitoring systems that had come inspired by Google and by Netflix has Atlas. Google created Prometheus, and there's other ones where they created these dimensional metrics. And that dimensional data model is the important part. So, this is from the Micrometer homepage, and it says that it gives you a dimensional data model that when paired with a dimensional monitoring system allows for this powerful kind of query thing. So let's talk about dimensional metrics versus hierarchical metrics for just a second. The hierarchical metrics are how I got introduced to really collecting these metrics with Drop Wizard metrics, if you're familiar with that library. Stats, other things, where you might have a metric where on this given server 1, for its HTTP requests, there were 10. So it's very, very straightforward. You can tell where it came from, how you group it. If you're going to query, you'd group on a given level. Dimensional metrics, they record the same things, but they track it a different way. So in this case, the second one is a dimensional one, right? So the following question then comes where, what if I want to add some more information? What if I want to track by cluster or region? What if I want to include URI information for these metrics or response codes? Or what if when I'm collecting it, I want to go and add extra metadata? In fact, there was a bug open against the Cloud Foundry build pack in Micrometer just in last month where Cloud Foundry was trying to go and add in a bunch of extra metadata for people that were using Micrometer, and it broke a bunch of these hierarchical metric systems because now it was telling them their Cloud Foundry instance and their version and things like that, right? So the dimensional ones are more flexible. So say we took that information we were just talking about and we wanted to add that to the metric. A hierarchical one, you have to find somewhere in the hierarchy to put that data, right? And sometimes it doesn't make sense. Take for example, the US East, okay, that's the region, that seems kind of clear. Blue, I'm not sure what that means. Maybe there's the tribal knowledge that we know that the second thing is the cluster, maybe not. But that relatively fits into that hierarchy, okay. But then you look at the end where we've got the 200 and users. Well, does the URI is more important? What am I going to group on in that case? And so that's where it's not always the best fit. When you compare with the dimensional layout, then instead it's just tags and it makes sense. So you can add more things on without breaking other things. You can ignore tags you don't care about. One other thing to point out is tags are all strings. So even though you might have a status of 200, you're not going to be doing math with it. So you can't really, you have to turn it into a string before you store it. Okay, so Micrometer gives us those dimensional metrics. And when we start getting a lot of metrics, it lets us think beyond monitoring. So I like to think of monitoring as just looking for errors and making sure my system isn't on fire or falling over. There's not a reason to panic, versus understanding the system and having much more insight into what's going on. So understanding the system is in the DevOps circles, or SRE, they talk about this term of observability. And they'll break it into kind of this tripod of three kind of pillars. We've got logging, metrics, and tracing. So logging is the detailed information about individual things that are going on. We're all quite familiar with logging. That's your first hello world where you're writing something out, right? That's your detailed information. Metrics takes the aggregate approach of various actions going on in your app. And then you got tracing. So I won't be digging into tracing in this talk. We don't have enough time for that. But I did want to acknowledge that it's there. So the concrete implementations, the libraries you might use for these different aspects is you might use SLF4j as a facade for your logs. And then that goes to a concrete logging system like Logback. Then with metrics, there's some really cool parallels where Micrometer becomes kind of that facade like SLF4j, and it might use Prometheus as its data store. Okay, and then Zipkin is the tracing equivalent. So as Micrometer was initially being created, we had a number of conversations around, well, we got this feature, and we wanted to think, how should we implement it? And it was very nice to use the logging metaphor as parallels. For example, with a library like Spring, they might want to log out what they're doing. And they don't want to impose their logging choices on someone that's consuming that library. So they'll use a facade. Spring uses Commons logging. SLF4j is a very common, popular one as well. Next thing is you might have log messages that are very noisy and chatty, and you want to be able to mute those log messages, right? So we need kind of the same thing with metrics. If someone's giving me metrics that I don't really care about, I need a way to turn those off. Next, with a log system, you might want that log message to go to multiple destinations, right? To console, to file, to some centralized network location like Splunk or Sumo Logic or Elasticsearch. And then another part is users might have some kind of common metadata, like when a user comes in, they want to go and set that information so that all log messages that happen are able to include that, oh, Clint did this, Clint did that, without manually going and putting that information in. And so in logging, you've got the MDC, the map to diagnostic context. If you're familiar with that, that's a thread local kind of thing. And so Micrometer has kind of an equivalent common tags is what we call it. So here's the mapping crossing where for the facade, Micrometer has this meter registry concept. For muting, we'll use meter filters, and we'll dig into and demonstrate using some of those in the demo. When you want to send to multiple destinations, Micrometer has this concept of a composite registry. And so that's a composite of multiple registries. And then for common metadata, you've got common tags. So we'll look at each of those things. Okay, one last bit before we get to the demo. There are some terms I want to make sure we were kind of clear on those. So you'll see a meter. We talk about meters, and a meter is a thing I'm measuring. So you might have a counter, and a counter, pretty obviously, is measuring one thing, the count of how many have happened, right? But then you might have other things like timers, which are more complex, because they might be measuring how many timings have I taken, and what's the total duration of all those timings, things like that. Okay, so a meter is kind of that base unit that a meter registry holds, and a meter registry, as you'd expect, is the store for all those meters. Then you have a tag, and a tag is those dimensions on those meters. So kind of like when I demonstrated the dimensional metrics earlier, you saw a number of tags there. And then you have a metric. So a metric is what is output at the end. This is what the metric systems are going to be tracking, and those are individual measurements. So for example, a timer actually goes and creates, by default, 3 metrics. It's total counts, total durations, and a max, things like that. So just so you can kind of break those apart. The main thing is telling meters and metrics apart. Okay, so let's start with a quick demo. And this demo, well, I wanted to show you kind of Micrometer from the ground up. And so this is, we're going to start Micrometer, and we're just going to not have Spring involved. Rest assured that all the things that we're manually doing here, Spring does for us automatically. So it's kind of nice to see, know that there is no magic. It's just wiring things up quickly. So we're going to use, we'll demonstrate the simple meter registry, the logging meter registry, the composite meter registry, as well as a number of meter filters and counters, timers, and gauges. So we'll go over here and hop into IntelliJ. Let's see. So I'm going to create a new file. In fact, we'll delete my previous one. Actually, we'll just do a file. we'll start off creating a main method. Whoops, I want to find my cursor. What's going on here? There we go. Okay, so here we're just creating a main method, and we'll increase the size so you guys can see it. Is that better? Okay. So we'll run our main method real quick. Okay, so for this example, we want to measure a number of things. And so a quick example I thought of was creating a list of chores that I need to complete. So in the case of a chore, I might name my chore. My chore has a duration. And also, we'll eventually get to grouping that chore. So we'll create a group for it and default it to home because I'm doing my chores around the house. And one other thing is we're going to go and create an extension property on integer just to make it so that we can read our stuff a little clearer. That just makes it so we'll be able to put minutes on almost a DSL, because if you're using Kotlin, you got to do a DSL, right? That's my only joke, I promise. Okay, so let's make a list of our chores. Anyone have any favorite chores they like to perform? Let's say mow the front lawn. That takes about 20 minutes. Oops. That's yard work. And then mow the backyard. Mine's small, so it takes 10 minutes. Maybe I'll gather the laundry. It takes 7 minutes. Wash the laundry, use my robot, my washing machine, and then we sort and fold. That takes forever. Then, what's something else? Wash the dishes, right? That takes 10 minutes. And what's one more? Find my phone charger. I asked my kids to do it, and they're really fast, so we'll do that at a duration of 5 nanos. Okay. All right, so here's an example of our chores. So now let's go and just iterate over those real quick. Almost done with the setup. So we'll do our chores. And for each one, we'll print that we're doing it so you can kind of visualize that. Print. Oh. Doing the chore. Okay, there we go. So let's run that one more time, and then we can get into actual demo. There, I printed that out. All right, so now let's go and add a micrometer. So we'll create our meter registry, and we're going to start with a simple meter registry. This is an in-memory meter registry that a lot of the various implementations extend this one to be able to start. So with our meter registry, we'll go and get a counter. So just pause here. So when you get a meter registry, you've got these methods to go and create gauges, counters, timers, etc. on it. So we'll go and create a counter. A counter. We'll call this chores completed. Completed. And we increment that counter. And then last of all, let's go and iterate over that so we can kind of look to see what that metric was doing. So we'll go and grab the meters, and we will iterate over them. And we'll go and grab the meter's ID. And ID is the name of its tags, and then we'll go and output the meter's measure. All right, so now we've got micrometer in here. So let's look to see what it looks like. That console is a little small, but we'll zoom in that way. All right, so here we have the chores completed metric, it's a counter, and it had a single measurement, the count. So there were 7 chores that we did, and it was done. So pretty straightforward, and nothing too surprising. All right, so now let's go and add in a timer. And a timer behaves the same way. We'll call it chores duration. And in this case, we're going to record our timings, right? And so I don't know if you can see the signature there. We can give it a double, so it just records the value straight up, or we can give it a lambda, in which case it will execute that and measure it itself. So in this case, we already have a duration, so we'll do the chore.duration and record that value. And we'll run that. So what's happening is every time it's going in here, it's looking up that timer and adding a duration. So here we have our chores duration. Down here, our timer. And it's got a number of measures, like I mentioned. One thing that's interesting is notice how there's an overlap, right? The counter measured a count of 7. Our timer also measured a count of 7, right? So if you have a timer, you don't necessarily need a counter to count that you've done stuff. The other parts we have here is the total time, and so that behaves also like a counter, where it's that monotonic, always increasing number, so you can use that same math and expectations that that'll always be going up. And so if it's always going up, that's not too useful. But if you, in your monitoring system, were to say, okay, I want to see how much it's increased in the last minute, then it becomes very useful, because you can say how much is the total increased, how much has the count increased, divide that, and you have an average. Then you also have this other bit, a max. And this is kind of an unusual one, but it brings up a good discussion point, where systems, you'll typically see a lot of averages or medians or 80th percentiles or 90th percentiles. And it brings up a good question of, if I'm looking at the 80th or 90th percentile or a 99th percentile, what am I afraid of in that last 1 percentile or the last 10 percentile, right? Someone is experiencing that latency, and I need to know about that. And so if you're looking at a lower percentile, you're missing part of the story. And so Micrometer by default includes this max. A max isn't useful if it's an all-time max, right? If it's a high watermark of all time, you know that at some point while this service has been running in the last week, that someone had really bad timing, but that's not useful. So instead, this is a rolling window max, and so by default, it's a 1 window max. And so you can graph on it and say, hey, what's the slowest we've seen in the last minute? And so that way it becomes quite useful, because you can see what's the worst case as of now. Because say it was very slow on startup, but now you've been running, everything's warm, you should be getting good timing. So that max is quite useful. If you don't have any requests, what do you think the value will be? It'll reset to 0. So if you see the max go to 0, that just means I haven't had any requests, so there is no max. All right, let's go back to the demo. One other thing I want to add in is, okay, now let's actually talk about the composite meter registry. So the composite meter registry, we'll go and run that real quick. Zoom out so we can see our screen. Okay, so if you look at the composite meter registry, notice that our values are now zeros, because it's a composite. It's going to forward onto other things. It by itself isn't going to be keeping track of metrics. It does. It's not obviously returning null timers and stuff, so that it is handling composite things, so that once it does get things added to it, once it does have repositories added, it can start recording those values. So let's go and do that. So we'll go and create our simple meter registry. Oops, let's call it simple. And we're going to add that to the composite meter registry. So meter registry.add, and we'll add it there. And we'll iterate over the simple one for output down below. And since we're doing composite stuff, we'll go and add in a logging meter registry. The logging meter registry, as you'd expect, just writes out to your logs, and so that's useful there. But it has some other differences. By default, it writes out every 1 minute, and you can change your config to do that. I'm going to go and copy and paste, so you don't have to watch me rejiggering that. Okay, so here I just have a config where I said that its duration is going to be 10 seconds. Actually, let's make it to 5, so you don't have to wait so long to see what it's doing. And then we go and add that to the composite meter registry. One other thing to point out, in fact, I'll do this right here, is sometimes you might have code where you can't inject in a, come on. you can inject in any properties. It might be really old code. It might be run by some other system that doesn't have the right injection capabilities. And so in that case, you got this metrics global registry, which is a static that you can go and reference. And this is the same one that Spring wires into. So you've got that reassurance that it's the same reference, but you can get to it if you don't have dependency injection as an option. All right, so let's run this real quick. Oh, one other thing we need to do is when we're logging, if it's going to log in 10 seconds, we probably need to hang around for it to log. So we'll wait for 100 seconds. Oh, are you not? Oh, we need 2 dots. And then we'll just sleep the thread. Sleep. All right, there we go. So we see that it is writing out our timer, and then we can see the logging meter registry is also logging out its metrics right here. Okay, now that we've got both of those in play, we'll stop it. We don't need to wait the whole time. Let's go and add in, you know what? We didn't do anything about tags. So let's go to the timer, and let's go and add in some tags around that timer. And so we're going to put in the name. So the chore.name. All right, so now we got some extra metadata around our timer. So we'll be able to see, we'll be able to aggregate on this and look at and break that up. However, what you see here is, we'll kind of stick up here. In fact, let's make that even bigger. Okay, so now instead of just one timer, we have 7 timers because each tag was its own timer. And so this is something we call a high cardinality metric. So name is to fine grain. Let's do the tag group, and then let's talk about why you'd want to avoid doing what I just did there. It's very tempting to add in a lot of metadata around your metrics because, you know, if I want to measure how long it took for this request, what if we go and add a metadata of the user that's logged in, and I can see how long it takes for each individual user and which user's slow, right? That's very tempting, but you're going to have a problem there. So let's talk about that. So back to the presentation. Okay, so this concept of metric cardinality, this is how many metrics I have. So imagine this first one where I don't add any other information, I just track all of my HTTP requests that I've served up, then that's pretty straightforward. I've got a cardinality of 1. Okay, let's add some more metadata. If we start adding the URI and the methods that are getting executed, now I've got a cardinality of 3. It's increased, but it's still a finite amount, right? Also, you'll notice, like with the user ID, that we are using some variable templates. And so this is actually more or less what Spring does by default when it's tracking your HTTP request. It's going to use your URL, your path variable templates in there. The problem comes where if you don't use those variables. So if here in this case, we're getting actually the ID itself of which user is getting looked up, right? And that's just going to grow and eventually explode. So this is what we call a cardinality explosion. The term comes from the Prometheus community. But essentially, it's when you might have a metric and you're adding in a tag that might be an ID or some timestamp or something, and you just have this growth of metrics. So the consequences are you're going to have increased memory usage, so far that you could get it out of memory. You'll have increased load to your monitoring system. Let's say that you're running it. Then that system's going to have either a lot more storage, a lot more memory usage, or if you're using a third party, then you're going to have increased monitoring costs. And those third parties are not super helpful in telling you, hey, by the way, it looks like you just tripled your monitoring expense. They just say pay here, right? So let's talk about how you can keep those tags under control. So you don't want to use user input directly as your tags on your metrics. It can be tempting. You might want to filter it. And so we've got this meter filter concept, and so we'll demonstrate that in the demo. And so that gives you the concept of disabling noisy meters, maybe rewriting tags that are high cardinality. Also, you can just outright cap your meter count so that it doesn't go above a certain number. Also, some systems like Prometheus, they have a concept of dropping metrics when you've passed a count too much. So we won't be looking at the Prometheus implementation, but that exists there. All right, so back in here, let's go and do that. So for example, we notice that there's a duplication between our timer has a count and our counter has a count, and it's the same number, so we don't need one of those. And so we might go to our, we'll put it up here when we define the meter registry. So we might go to the meter registry. Actually, you know, we'll put on after, just to keep those grins there. So there we added all the registries. We go to the meter registry, and you can get its config, and you can add in a meter filter. So there's some built-in meter filters you can use. So in this case, we'll do a deny meter filter. And if its name equals chores completed, then we want it to not be allowed in. So essentially, it'll create a no-op counter, and so you can see now we only have our chores duration. So that's one way you can drop it that way. Let's say we still have too many metrics, and so we want to go and create a meter filter for the maximum allowed metrics. And let's say we put 2 here. In your system, you'd probably put it some higher number like 200 or 2,000. There still is plenty of room for metrics, but for our demo, we had 4 before. Let's see what happens now. Now we only have 2. So these two approaches are lossy, right? There is data being lost, and I'm not going to really know what those counts are. In the case of the counter one, it wasn't so lossy because we had an overlap. So let's comment both those out. And so we're going to look at my preferred way. So the other thing that a meter filter can do, let's indent that, is you can rewrite tags. So we'll go and create a meter filter. And so meter filters are just an interface, and so we will override the map method, okay? Instead of having you watch me craft that map method, I'll grab it from my notes, and then I'll talk you through it. So every time a meter is created, then it goes through this map method, and that gives us a chance to go and change stuff. So in this case, we're checking to see if the name of the meter is chore duration, then we'll go and replace its tags. And essentially, if the group is equal laundry, we'll keep it. Otherwise, we're going to put it into the other bucket. So let's go and run that so you can see how that works. And this is nice because those counts and those durations that we're going to those other buckets, those now all get aggregated, and we don't lose that information. Oh, I missed a step. Why didn't that work? So we've got the, name. We're still calling it name down here. So we need to change that to group. What am I missing? Chores. Oh, I got a typo right here. Oh. We'll make all these. Thank you for your help. There we go. So now we have 2. We've got our laundry, which there were 3 laundry chores, and our other, which are the other 4 chores. And we still have all the timings and stuff like that. So that gives you a tool for lumping those together. All right, there was one other type of metric or meter that I mentioned I was going to talk about, which was a gauge. So let's look at how that works. And I intentionally saved it for last because I want to demonstrate one kind of feature of it has. So let's say the chore size, for lack of a better reason. And a gauge you would think is quite simple. You give it something to work on, and it just reports the size. Oops, that was plural. Now we have chores, right? And it's expecting a double. So all meters go by doubles because that's the common denominator between them all. So, all right, so now if we go look at that chore size, we can see that it's reporting that there were 7 in that list. So that's very useful. And that is not the gotcha. The gotcha is, let's say we're adding our gauge here, registry. And instead of adding the meter to gauge how we did there, oh, come on. What if instead I did something like this, where I had a chore list, and I created it from the chores, just quickly mapping it to a completely different array, and we go and use that chore list. So I'm going to give away why this is a problem with this right here. So, oops, chore, those S's are causing me trouble. Okay. So now you'll see that we've got our chore size here. It has a count of 7. That's all great. And we come down here to the logging one, and what have we here? We have a nan. So by default, gauges use a week reference. And so this gets asked on about Stack Overflow about once a week, where someone says, why did my gauge suddenly start reading nan? And that's because the corresponding value that you were using the gauge against was garbage collected. So there's 2 quick fixes on that, but I wanted to point that out so that you are aware. So let's go and we'll do each of those. So we're going to rename that size one to week because it's using a week reference. Let's use a lambda to solve it this way. And so one quick solution is maybe instead of using the value that's passed to it, we just go and use the chores list directly. And so that lambda is going to create a closure. It's going to close over that value and not allow it to be garbage collected because it is being referenced. And so that will address it. Another way that you can solve it is using the builder. So there are builders that you can use for creating your metrics. This gives you some more fine-grained control. So here we have the chore size, and we will call this strong. And it behaves the same as the other one, where we're going to go and get its size. It's double. But we can do one last thing. So we can say strong reference true, and then we can register it with the meter registry. So in that case, both of those will bypass that problem. So you don't have to jump through any hoops and try to store it in some other singleton somewhere where it doesn't get garbage collected. You can just use either of those approaches. As a kind of a silly side, it also fixes the weak one because it also referenced that, and so that the weak one's going to start working because it never gets garbage collected. All right, that is all that I had for that demo, I believe. Oh, there was one last part. We did talk about how if you have common information you wanted to add to all of your metrics, then you can use common tags. So here's a demonstration of that. And so I might say that the team is the spring team. I just promoted myself. Okay, so now what this does is it goes and makes it's doing the same thing using the same mechanism as the meter filter, so it's the same abstraction you could use. In fact, if you just go and look at it, you can see it's just using a meter filter of common tags. So that's just a shorthand there. And it behaves just like this other mapping one. So let's go in and we should see those common tags appear. So now you can see that all of our metrics have both the team tag as well as their group tag, even the gauges and stuff. Okay. Any questions? We will have some more questions at the end. We got a lot to talk about. Okay, so that was showing you how to wire it up from the ground up, just so you can see what are the moving parts and how can you hook into that. So now let's talk about the Spring integration, and this is where it becomes very powerful because, as we know with Spring Boot, it goes and wires things up for us, things that we would need. And so Micrometer from the get-go is built into Spring. It's already referencing a lot of these metrics and it uses them. And then the auto wiring happens where if I start using another part of Spring, say RestTemplate, that can also get wired in and I can start getting metrics on that without even doing anything. This continues to be useful insofar as there's a lot of integrations that Micrometer uses. And so if I go and use a binder, which we'll talk about those, then Spring also knows what that interface does and it can wire those up for us automatically. Then we'll get the integration for other libraries like Resilience for J, where they said, hey, this is a very useful abstraction. I'm going to use this as a first-class citizen. And so that's where the community starts taking off and using it. And that's a lot of reason why I wanted to show some of these finer features in Micrometer so that you could see how you could use it in your own libraries and know the cost benefit. it's all benefit, just so you know, right? And then you can also do custom stuff because all the abstractions that the other layers used, you can use them yourselves, okay? So we don't have time to go and actually go to start.spring.io, but to quickly set up, you can go there, start your project, use web and Actuator, at least in the case of Prometheus. And then you need to go and add the Prometheus registry yourself. So those are the corresponding Gradle additions to get that up and running, and that's what I've added to my project here. You need to go and turn on the actuators. So in the case of this project, we're going to enable the Prometheus actuator, which just gives you the Prometheus endpoint, as well as the metrics endpoint. So we can kind of compare how those two differ. We'll also look at the health endpoint. So all of those are there. So just by doing that and nothing else, you already have a number of built-in metrics. So you have a number of system metrics. So this is file system handles and how much of the file system is available to you, how many CPUs you have and the CPU load, the uptime of your process, which is kind of nice to see how long your system's been running. You'll have a number of JVM metrics around heap size, garbage collection, class loader, things like that, as well as the HTTP requests. And so that comes from Spring MVC, where it's going to go and put tags on the URIs and statuses, and we'll look at those examples. Tomcat also has a number of metrics it exposes. How many threads are you using? How many connections are active? How many errors is it served up? What are its sessions? So these are all very useful metrics, and you won't have to do anything. You just start getting them right from the get-go. One that I find immediately useful is the logging one, and you'll get a log back metric, at least by default if you're using log back. There's an equivalent for log4j. And what's really cool about that is you could go to your logging system, you can say, hey, how many errors have there been in the last hour, right? But since Micrometer is already publishing that as a metric, then you can do something like this. So this is an example of it saying, hey, give me the total count of errors in the last hour, and then give me that same count offset by 1 day. So the same error count, same amount of log message errors that I had a day ago, am I more than 1.5 times above that? And then you can start alerting on it. So you get some very powerful machine learning, if you will. Obviously, I'm joking there. Okay, so let's look at the metrics actuator. So in Spring Boot 1, they had the metrics actuator, and it was very useful. You could go look at it. It was a very hierarchical metrics, and it was limited. If you look at the new one, I would consider it deprecated. I'm obviously not on the Spring team, so I can't make that official declaration. But when you go and look at it, when you saw what we were putting out in our command line example, this is very much just a JSONified output of those measures and those names. And so if you have any code that is manually scraping this metrics endpoint, I'd really encourage you move to a real system like Prometheus or something where it's actually getting that value over time. Okay. All right, one thing that you don't get by default, and I'd like to see this change, but we'll explain why this doesn't happen, is your health indicators. There's this nice health indicator interface, so there's the interface up there. Just you call health and it returns a health value. Spring knows about that, and it goes and exposes those on the health actuator. And so it can show if your database is up or your file system, or you can add your own ones. Those by default aren't turned into metrics, which is unfortunate because that becomes a very useful aspect for it. So there's a documentation on Micrometer's website where they give you an example, code that you could really drop into your project and turn it into a gauge. And the reason why it doesn't exist by default is really you can have unlimited values for health. So health status is a string and it's not an enum, so you could make whatever status you wanted. So, how would you map that in is one question. But then the other problem is by default, every time you call health, it's doing an actual health check, and that can be slow. And you want your metrics endpoint to be quick, and when your metrics are iterating through your meters, when it gets to gauges, it's going to execute the Lambda, and it could be slow. So you want to have a solution for that. So here's how I implement it by default, where up is a 1, a positive, and then down would be like a -1, right? So that becomes very easy for me to say, hey, show me are any of my health indicators negative, and if so, how far negative, things like that. So in the sample code that you can check out, I also wrap it in a thread, a task scheduler, so you can see how we take care of the fact of them being slow sometimes. But that becomes a very useful metric right from the get-go. So now when we look at how we start using RestTemplate and get metrics around it, this is all you need to do. If you inject in the RestTemplate builder and you call build on it to get your RestTemplate, it will already have the metrics built into it. And if you want to do it yourself, you can just go and grab the metrics client HTTP request interceptor and add that as an interceptor. So it's very straightforward, very easy to do. The one gotcha, though, is notice how when we do this get for object down below, we want to make sure we use the parameterized, the URI template, right? Because if we put in a number there, then we're going to have that cardinality explosion. So that's why I explained it. Even though you probably won't run into it, and especially if you're using the Spring stuff, if you do call it the wrong way, then Micrometer doesn't know, okay, is this a unique tag or not, and you could get more meters than you intended. The way that these things get wired in is the binder interface, and this comes from the Micrometer project directly, and it's simple. It just has a register, a bind to method that you can implement. And any beans that implement the binder, the meter binder interface, will go and get bound to the meter registry for you by Spring. So I'll demonstrate one of those. What's really nice is if you go look at that interface and find everything that's implementing that interface, you can look through and see what are all the meter binders that are available to me if there were some that you wanted to use. Like you might notice some like caffeine cache metrics, data source pool metrics, cache, executor service, file descriptor. So there's a lot of them. A lot of those get wired in for you automatically, but at the same time, if you're curious and looking around, hey, what are all the other metrics I could add in? So speaking of caching and that caffeine one, Spring will, if you're using @cacheable, there's a number of metrics around hits and misses, or the size of your cache and things like that. That's very interesting to find out, is this cache even doing anything useful? If you're using a loading cache, you can have metrics around how long it's taking to load that cache, things like that. And so you can let Spring wire it in, or you can use the binder directly like you see right here where the middle line, they're using caffeine new builder, and that goes and creates you a cache, and then you just wrap it in the corresponding monitor that binder provides. One last thing before we go and look at some more code is the resilience for J aspect. And that one's really cool because not only do you have experts who know what are important metrics around resilience for J, hits, misses, circuits being open or closed, the states of those kind of things, durations, what's slow, so they can make metrics that are specifically useful to you, but then also you can they'll go and share dashboards. So let me show you what that looks like. So if we go back over to here, over on Resilience for J's website, they in fact have a section where they talk about Micrometer, and they even talk about Grafana, and they say, oh, hey, you want a dashboard that tracks your states of your various circuits and how they're behaving, then you can just import in their let's see, where is it? This is the link. So you can just import that JSON into your Grafana, and you'll have a dashboard that has all those values. And maybe your tags don't line up exactly, but it gives you a very good starting point where you can start tweaking it. So that's really where the power of Micrometer comes forward. All right, so let's go back to our project. So here I've got a simple Spring Boot project that I mentioned. I've only added one bean to it, so a thread pool task scheduler. And then here's a HealthIndicator binder. So remember how I was telling you about the meter binder interface? So we go and inject in our health indicators. We go and iterate over them and put them on the executor so that every 10 seconds, or probably more realistically, it should be every minute or 5 minutes. But for the purpose of the demo, we'll make it go fast. Then it will go and look up the value of that and cache it. And then that way our gauge is just going and looking at that latest cache value so that it can report on its health. So let's go and look at that. All right, so we've got it up and running. So this is what the actuator looks like. So these metrics look more or less like how the dimensional ones I explained earlier were. So let's see, what's a useful metric you would be interested in? So if we go and look at the HTTP server requests, so it's wrapping, which makes it a little harder to read. So let's see. So here we have the hello API. We'll go to right there. Oh, man, that really... so you can see how many counts have been called on that. So here we've got the count. And so that's been called 1,000 times, right? And that's when it's received a success, which is a 200, right? But then you have some failures, like a 503. You got some 404s. And so you can go and break down how many of those are happening for each of your URIs. Also, you have the total seconds. So that's the sum right there. So that's where it's the total duration that endpoint's taken. And again, if you have a total divided by the count, you can get an average. So That's the default one that Spring gives us. I should have included some, oh, I did. No, I should have included some where I used path variables so you could see those in use. Let's see, another metric that is interesting to us is the REST template, right? So that is the HTTP client. HTTP client. So now we can see, you know what, I'm going to do it this way. There we go. Okay, so here we've got the HTTP client requests and which responses they're making. And unfortunately, I'll highlight these two. These are the two you care about. So we've got the total counts that were happening and the total duration of making that request. Again, we see the URI templating taking place, and that's very, very useful because we don't have that metric, the cardinality explosion. We also see that some of them are failing and how long those are taking to fail, or how many of them have failed and what's the duration of that failure and so forth, okay? And the last thing is we have that max that we talked about where we can see what's been the slowest in that minute, okay? So we talked about having caches, so if we go and look for the cache metrics, if I could spell it, cache. So we can see that user cache that we talked about, and the resilience for J. Resilience for J. So we can see that the circuit breaker is in a closed state, so that means it's forwarding values, and I'll show you the code for where we leverage each of those values. We also have resilience for J. How many of its calls have failed for our user lookup? How many have been ignored because it was over capacity? And how many succeeded? Things like that. All right. So that's all of those metrics. So let's go look at how those were implemented. So here I've got a simple user service where we inject in that REST template builder. We build it and that gives us our metrics. And we're able to go and use it using those templated variables, right? Then with the case of the cache, as I demonstrated on the slide as well, we just go and use the caffeine cache metrics binder and wrap the cache, and then that way we can kind of track its usage. Here's resilience for J, where we've got a lambda for what we do when we want it to succeed, and when the circuit opens or when it fails, to use the fallback of using our cache, or if that cache is empty, using just an empty list. So that's a quick overview there. I apologize for the speed, but I wanted to show you all these features without the slow time of me coding them all up. Okay, let's see. All right, looks like we're doing pretty good for time. So as I mentioned on the presentation, it was about, hey, how would we measure front-end metrics? And this is more kind of a open-ended kind of aspect because unfortunately there isn't really a way that Micrometer, being a JVM library, how it could go and track what's going on in the browser. But I am going to demonstrate how you could track stuff yourself, grab the timings that the browser does give you, and send those back. I would be interested if anyone wants to collaborate on making a formal actuator for this, but for now we'll use what we got. So here I've created a simple Angular app. Let's go clear out the network tab. And essentially, as I switch between the various values, imagine if I'm switching between URLs or looking at different components, stuff like that, I want to go and grab that and send that back. And so we'll click a bunch, generate a little bit of traffic. And so you'll notice that I'm making these, every 5 seconds, we're sending some metrics to the back end. And these, is it going to let me make it larger? It's just a very simple payload of which component was active. In this case, the favors and the users. Here we had 2 calls to favors, 2 to users, and so on and so forth. So I don't expect you to grab my code and drop it in, but it gives us a way to say, I've got a custom value that maybe you're not getting it from the front end. Maybe you're getting it from a database, and you want to express those counts as a Micrometer metric. What would you want to take into account there? So in our demo app, I've got an analytics controller, and so this is a poor man's metrics. But it's quite powerful insofar that it's sending us that map of metrics that were collected on the front end, right? And so I was going to iterate through them. I want to know, okay, have I gone over my cap? So essentially, if someone's malicious and they're just sending me random values, I want to account for that and then maybe log that out. And so we can cap it. I have it capped at 3, probably more realistic. You know, you change it to something more useful, but in our case, we got so few. And then all we do is we go and grab our, we go and use that as a tag on our client visits metric, and we go and increment that counter. So again, we're just using a counter here, but it gives us a very powerful stuff. So if we, let's refresh this, and we look for that client visits. So we're going to see that we've had a total of 4 to the user's endpoint, our component, and to the favors, and then 2 to the request component. So, because often there's other things you want to kind of generate on the fly and create your own metrics. So there's that. I don't know that the Angular code would be that interesting to this audience. Let's see. That is all, and we finished with plenty of time. So thank you for coming, and I'm open for questions now. Yes? Sorry, for heat maps? Yeah, so Grafana has a heat map chart, in fact, and so you could just say, change it to a heat map. I haven't worked too much with it, so I don't know the specifics, but it does support that. Okay, that's it. Thanks for coming, everyone.